Force of pressure. A liquid in a container applies force to all surfaces in contact. The force applied to the surface of the container is called as the force of pressure. And it is calculated as pressure is equal to the force over area. So when we multiply cross-sectionally, then force is equal to the pressure times the area. Pressure is the pressure of the liquid at the base of the container. So it is equal to the density of the liquid, the depth, and G times the area of the surface, A. So for liquids, the force of pressure is equal to dAGA for liquids. What about for solids? For solids, the force of pressure is equal to the weight of the object. Because for solid, we have said that pressure is equal to force over area, where force is the weight of the object. When the base surface S2 is taken, the height h is taken. But when the side surface h1 is taken, the average height h/2 is taken, because the force of pressure is accepted to be applied to the midpoint of the surface asked. So when the force of pressure at the surface S1 is asked, you take the midpoint of the surface and find the depth of this midpoint, where here it is equal to h/2. So the force of pressure 1 is equal to the density of the liquid, the average depth, G times the surface S1. The force of liquid at the base of the container, here the depth is equal to h. So the density of the liquid, the depth h, G times the base area S2 will give us the force of pressure at the base of the container. We have some conditions here. If your container is like this, a cylinder, then the force of pressure is equal to the weight of the liquid in the container. The F at the force of pressure at the base of the container is equal to the weight of the liquid. If your container is getting wider, like this, the force of pressure is equal to the weight of the liquid in the dashed part of the container, as if there is liquid just here, not this part. Because the weight of the other amount, this red part, is balanced by the surface of the container. So here the force of pressure is smaller than the weight of the object. In the third container, you see that it's getting narrower. The force of pressure is equal to the weight of the liquid in the dash part of the container, as if there is water also in these empty parts. So here the force of pressure is bigger than the weight of the liquid. In this example, the pressure and force of pressure at the base of the container is P and F in the figure 1. The liquid is then poured to the second one. What will be the new liquid pressure and the force of pressure in terms of P and F? Now, here the pressure of the liquid will be equal to the density of the liquid, the depth equal to 2h times G. And the force of pressure is equal to the pressure of the liquid times the base area 2s, which is equal to 4 dAg times S. Now this liquid is poured to the second container. Now we have to find the new level, the new depth of the water. How can we find? From the conservation of volume. The volume at this container should be equal to the volume at the second container. So as the volume are the same, I can say that this part 2s times h plus this part h times s should be equal to 2s times x. So the new depth is equal to 3h over 2. So the new pressure will be equal to the density, the new depth, and G. This value is equal to 3 over 4 times the previous value of the pressure. Now let's find the new force of pressure is equal to the density d 3 over 2g times the base area 2s, which is equal to 3 dhs, and this value is equal to 3 over 4 times the previous value.